Sorry, that made a lot of racket. I was trying to move it so it would catch my voice a little better. Okay, so chapter 5 is on solving systems of equations. So to start with, we're just solving 2x2 systems. But this first example is just, can you tell me if it's a solution? So to determine if an ordered pair is a solution, you just plug them in and see if they work. So you have an x value and a y value. So into the first equation, if we plug 1 in for x and 2 in for y, we're going to get 2 minus 6 is negative 4, which is true. If it's false for the first one, you can stop. If it's true for the first one, you got to check the second one. So we plug into the second one, we'll have 2 times 1 plus 2 is equal to 4. So 2 plus 2 is 4. That is true. So yes, this is a solution. Alright, so for B, again, this is x, this is y. So if we do 2 times 7 minus 3 times 6 is negative 4. You're saying 14 minus 18 is negative 4. Check that works. Alright, so what about 2 times 7 plus 6? Is that 4? Well, that's 14 plus 6, which I'm pretty sure is 20, not 4. So since it doesn't work, this is a no. So when you plug them in, they have to make both equations true for it to be a solution. Alright, I jumped over the definition of a system of linear equations. It's 2 or more linear equations. Well, for linear, it's just 2. What we're going to do tomorrow aren't actually linear. They have 3 variables. So a system of linear equations is 2 linear equations where one ordered pair is the solution to both. Alright, so next, to solve that substitution, you have to get one of the equations solved for a variable, substitute that into the other equation. You're going to finally find a variable and take that and plug it back into one of the originals. So let's just work it out. So when you're looking at your 2 equations, substitution is never your friend when there are numbers everywhere. If x and y both have a coefficient in both equations, you do not want to use substitution because it's going to make you work with fractions and y'all really don't like that. Alright, so since we don't have a coefficient here, we can use substitution. We just need to take this equation and solve for y. So I'm going to subtract 2x to the other side. So we know that y is equal to negative 2x plus 1. Alright, so from there we can say that y is equal to this. So we're going to plug it into the other equation for y. So that now says 3x plus 2 times negative 2x plus 1 equals 4. So 3x minus 4x plus 2 is equal to 4. So negative x plus 2 is equal to 4. So negative x is equal to 2, because I subtract 2 from 4, which makes x equal to negative 2. Alright, at this point, you take what you got here, and always plug it back in here. It doesn't really matter where you plug it in, as long as it's one of these 3 guys. Alright, so we have negative 2 times, so we're plugging in a negative 2 for x, plus 1. So we get 4 plus 1, so we know y is 5. The solution to a system is always an ordered pair, so we have negative 2, 5 as the ordered pair. Alright, that was substitution. The other option is elimination, or the addition method, or the linear combination method. It's called a bunch of different things. Basically, it's where you put your 2 equations together and make a variable disappear. So if you need some steps, this is a good set of steps. So pause the video, write those down if you need to. Otherwise, just follow along and you'll pick it up. You've learned it a couple of times. Alright, so using the addition or the combination method, you're going to combine your function, your equations, to make a variable disappear. Alright, so if you look, the first thing you ask yourself is, if I just add the 2 equations, does anything disappear? So here I get 6, here I get 2. So I don't have 0 x's or 0 y's. So I have to make an adjustment to either make my x's match or make my y's match. I I tend to pick the ones that either, there's two ways to think about it. Either I can pick the y's because they already have opposite signs, or I can pick the x's because I can multiply one to make it look like the other. So going with the less work method, I'm going to multiply by -2 here because it'll give me a -4, which will cancel up here. So if I take this equation and multiply by -2, so my first equation stays the same. My second equation becomes -4x plus 6y equals -14. So now if I add those, you see that my x's go away. I have 11y equals -11, so y is -1. Alright, so once you've eliminated one of those variables, you figure out what the other one is, and then you can just take that answer and plug it in. It doesn't matter as long as it's one of the original equations, and you have to remember you're plugging in for y. So I'm going to go here because I can draw a line there easier. So we have 2x minus 3 times -1 is equal to 7. So 2x plus 3 is equal to 7. So 2x is equal to 4, which means x is 2. Alright, so my solution here is 2, -1, written as an ordered pair. Remember, it's x and then y. Alright, so over here, when you first look at it, you're like, ooh, it's a 3 and a -3, but they have different variables. So the first thing that I'm going to do is write this as 2x minus 3y equals 9, and 3x plus 4y equals 8. So I subtracted 3y and I added 3x so that I have both of my equations in standard form. Alright, so now, to get rid of the x's, I've got to multiply both and make them a 6. Here I have to multiply both to get them to be a 12. These already have opposite signs, so I'm going to pick those. So here I would multiply by a 4, and here I would multiply by a 3. So that gives me 8x minus 12y equals 36 for the top. 9x plus 12y equals 24 on the bottom. This gives me 17x. This cancels. This gives me 50. Nope. It should give me what, 60? Alright, so I'm second guessing myself because my numbers aren't working out nice, but 4 times 2 is 8, 3 times 3 is 9, 9 plus 8 is 17, 4 times 9 is 36, 8 times 3 is 24, and 24 plus 36 is 60. Okay, so we do get 60/17 as the answer. Right, answers are not always pretty, but I didn't remember there being a yucky one on this. Okay, so now that you know your x, you can take that back and plug it into one of your originals. I'm going to plug it in here. Yeah, that's fine. Alright, so let's see if I can get it where I can see everything. So that is 4y equals 8 minus 3 times 60/17. So 4y equals, I'm going to type this on my calculator and then do math, enter, and get a fraction. So I'm going to do 8 minus 3 parentheses 60 divided by 17. And then math, enter, and I get -44/17. Alright, so then we're going to divide by 4. So I have this in my calculator, so I'm just going to divide by 4, and it tells me that the answer is -11/17. So my answer is 60/17, -11/17. Alright, let's see what else we got. Okay, so the number of solutions that a system can have is 1, because 2 lines can only intersect in one place. It can have no solution if those 2 lines are parallel and they never intersect, or it can have infinite solutions if those 2 lines are actually the same line, so they intersect always. Alright, so some vocab words for you. that you should have heard in Algebra 1, because I know it's in that Springboard book. A consistent system is a linear system that has at least one solution. So consistent is going to be infinitely many, or if there's one solution. So if I have infinite or one, I'm going to be considered consistent. There's an answer. An inconsistent system is when there is no solution. Okay? So for a consistent system, if you just get one answer, that's what all the problems we've been working look like. For infinite solutions, it's when you end up with your variables. I was going to write something, but I can't really make it like succinct, so just listen. Infinitely many is when your variables disappear and you have a true statement. And no solution is when your variables all disappear and you have a false statement. All right, so let's look at one. So here, it looks to me like I can multiply the top equation by 2. And I'm going to cancel out both things, but my bet was, let's just make those match. But then I realized, hey, those are going to match too. Alright, so all of these multiplied by 2 and gave me this. And then I just rewrote this one. So now let's add. These cancel, so there's nothing here equal to, what is that, 22? Alright, so does 0 equal 22? No, it does not. So this is infinite solutions, which makes it consistent. This is the answer, that it makes it a consistent system. I literally just wrote the wrong thing. It clearly is false, so it has no solution. Golly. And it is inconsistent. So back up, pretend like that didn't happen. We will fix it. It's a false statement. So it is no solution. Which if you want, you can write like this. And it's inconsistent. Using those new vocab words, which I'm not going to ask you for when you take a test, by the way. Alright, so next. This one's set up nicely for substitution, so I'm just going to do that. If I take this, I can plug it in here. So I have 5 times 4y minus 8 minus 20y equals negative 40. So 20y minus 40 minus 20y equals negative 40. You see that these guys cancel, and you have negative 40 equals negative 40. That is a true statement, which means we have infinite solutions, or infinitely many solutions. So you can write it like this, IM. And it is consistent. Consistent. So again, these are new vocab words, but you're not going to have to give me that part on a test. I just need you to give me this part or write it as infinitely many IM. Alright, I was observed 1 year when I did this. We did a scavenger hunt. We're not doing that. This is your assignment. If you have questions, please let me know. Usually it's like you lost a negative. So just work and let me know if you have questions.